subscribe to our YouTube channel, Joylearning TV.
Hello viewers, welcome to SHSR on Joylearning channel. I am Wisdom Agbesinyala. Many community is the one. In this lesson, we'll be looking at ionic product of water, pH and pOH, examination style questions, and we'll end up with a summary. You heard me say pH and pOH, and that is enough to tell you that this is under acids and bases. You deal with acids and bases in your homes. You eat tomatoes, you have vinegar in your homes, you have washing powder, and so on and so forth. And then of course our very good friend water that we drink day in and day out. So water is considered to be a very weak electrolyte. Somebody may ask, what is an electrolyte? It's any compound that conducts electricity in its molten or aqueous state. So if that is the case, then water can dissociate partially, producing an OH ion, and H plus ion. Now, because it is dissociating partially, it establishes equilibrium. So if that is the case, we can write the equilibrium constant for the dissociation of water. So that is the Kc, that is the equilibrium concentration for water, will give us the product, that is OH concentration times H plus concentration all over the reactant. So what we have here, we have two ways of representing, that is water and water, to produce the A3O plus, that is the hydrozonium ion, plus OH minus ion. Or simply, I can just write water, dissociate it into H plus and OH minus ions. So to write the Kc for this, we have the concentration H plus ions times that of OH minus ions, all divided by water, that is the reactant. So I can make the product, that is H plus concentration times OH minus concentration, the subject. That will give me the Kc times H2O concentration equal to the H plus ion concentration times OH minus ion concentration. Now, to establish this, we have to make some assumptions. As I said already, water is a very weak electrolyte. It ionizes on itself. That's what we can refer to as autolysis of water, self-ionization of water. And then, of course, we are dealing with water, which is liquid, pure liquid. It's also a constant, practically, at a specific temperature. So if that is the constant, Kc is constant, and then is also a constant, that will lead us to the ionic product of water. So at this point, we should be able to define what ionic product of water is. So from what we have seen so far, we can define ionic product of water as the concentration of H plus ions times the concentration of OH minus ions. I mentioned that at a specific temperature, that is room temperature 25 degrees Celsius, it is known that the ionic product of water is set at 1.0 times 10 negative to the power negative 14. And of course, a unit mole square dm per minus 6. So because equilibrium constant is affected by temperature, the ionic product of water must also be constant at its temperature. Moving on, if we have equal concentration of H plus and OH minus ions in solution, then we describe that solution as a neutral solution. So it means that from what we have stated so far, Kw equal to the concentration of H plus times that of OH minus concentration, we can equate the concentration of H plus ions times that of OH minus ions to be 1.0 times 10 power negative 14. We can do substitution because we said that in a neutral solution, the H plus the OH minus ion concentration. So we can replace one by the other. Therefore, wherever I see OH minus ions, I want to replace it with H plus ions. Or you can also do it the other way around. So when I replace the OH minus ions with H plus, I'm going to have concentration H plus squared equal to 1.0 times 10 power negative 14. So from here, I can take the square root of 1.0 times 10 power negative 14. So I can have concentration H plus equal to root of 1.0 times 10 power negative 14. So the root of 1.0 times 10 power negative 14 will reduce to 1.0 times 10 power negative 7. And of course, we can conclude that for the OH minus ions, concentration is also 1.0 times 10 power negative 7. The unit moles per dm cubed. So we can make an assertion that the concentration of H plus ions, when it is greater than that 1.0 times 10 power negative 7, then we can describe that solution as an acidic solution. And if it is less, then we can say that is a basic solution. Because when the concentration of H plus ions increases, that of OH minus ions will decrease. So at the end of the day, it's going to be constant. We now want to look at pH and pOH of an aqueous solution. So here we should be able to define what a pH is and of course what pOH is. So pH is the negative log of the concentration of H plus ions in solution. So you can give us the definition for pOH. Okay. Right, you got it right. So the pOH will be negative log of the OH minus ion concentration in solution. You got it right. So mathematically, we can write pH equal to negative log of the hydrogen ion concentration in solution. Now, of course, because of the negative there, I can rewrite as pH equal to log concentration H plus power -1. So in effect, I can write it as pH equal to log 1 on concentration of H plus ions. So if we have already established that the H plus ion concentration times that of the OH minus ion concentration equal to 1.0 times the power -14, then we can take negative logs because we are looking at pH. So if we take the negative log of both sides, then we can have negative log into bracket concentration of H plus ions times that of OH minus ions equal to negative log of 1.0 times 10 power -14. So from there, this one is no more chemistry. This is mathematics, logarithm. So from there, we can have neg log of the H plus ion concentration minus, because when we should expand this, we are going to have negative log concentration of H plus ions plus minus log concentration of OH minus ions equal to 14. So in effect, I can have negative log concentration H plus ions minus negative log times OH minus ions equal to 14. That is what we have there, and it reduces here. We have already defined that pH is negative log of hydrogen ion concentrations in solution, and then pOH is also negative log of OH minus ion concentration in solution. So in effect, we can have pH plus pOH equal to 14, and that is an expression that we can use in calculation. If you forget all things, don't forget this. pH plus pOH equal to 14. So if a question is asked, we should be able to remember this simple expression in our calculations. So the next thing is, how do I apply this in calculations? So let's see how to apply this. Calculating pH and pOH of a given solution. We have three ways we can do it. One way, we can be asked to calculate the pH or pOH or both of a solution. A solution can be hypothetical. We can just say calculate the pH of a solution, blah blah blah, and that we should be able to do that. Then we can also talk about specific solutions, an acidic solution or a basic solution. So calculate the pH of NaOH solution, calculate the pH of ACl solution, and we should be able to do that one. The third one is the most interesting aspect, where an acid is mixed with a base and you are asked to calculate the pH or pOH or both of the resulting mixture. How do I do this one? It's simple. Very, very simple, that we should be able to do. Right. So we continue with exam style questions and solutions. So the question number 1 is here. Calculate the pH of an acid whose H3O plus ion concentration is found to be 2.72 times 10 power negative 9 mole per dm cubed. What do I do? It's so simple. What is the working equation? pH equal to negative log of hydrogen ion concentration in solution. So you just quote that and then do your substitution and evaluation. So your substitution will give you 1 mark, and then evaluation will also give you 1 mark. So this question will give you 2 marks. And don't forget, this can also be in your objective test question. Very simple. Just quote the formula, do your substitution, and you are there. Question number 2. If the pH of a solution is 3.94, calculate the hydrogen ion concentration of the solution. So here pH has been given. We are looking for the hydrogen ion concentration. So the vinegar in your home, if you know the pH, you can calculate the hydrogen ion concentration in there. So here, the same way you quote the formula, pH equal to negative log concentration of H plus ions. But here, pH has been given to us as 3.94. So substitution 3.94 equal to negative log of H plus ions. So you take inverse of log, and that will give us the hydrogen ion concentration equal to 10 power negative 3.94. Or hydrogen ion concentration equal to 10 negative pH. So if you know the pH, you just substitute and then you evaluate. So from here, we have 1.15 times 10 power negative 4 mole per dm cubed as the H plus ion concentration. I hope you are following. So at the end, you go and look for more questions and try your hands. It's very, very interesting, very, very straightforward, very simple. Question number 3. So this one is your blood. So if you have your blood sample, you can find the pH of your blood. Determine the pH of human blood whose H plus ion concentration is 3.0 times 10 power negative 7 mole per dm cubed. So provide the answer for yourself. So this is your turn. Very, very simple. Quote the formula, do your substitution, evaluate for 2 marks. Okay. If you got it, then smile to yourself. The 4th question, this one too, you have to verify whether the answer there 0.46 is correct. If you don't have a calculator by now, please go pull your calculator, because we are doing simple mathematics. In NaOH solution, the hydroxide ion concentration is 2.9 times 10 power negative 14 mole per dm cubed. is its pH. So this is where you are going to apply the formula pH pH plus pOH equal to 14. See, here we have been given a basic solution, and bases release OH minus ions in solution. That is why we said that this solution is a basic solution, because of the OH minus ions in the solution. So the OH minus ions concentration has been given to us as 2.9 times 10 power negative 14. We are looking for pH. So it means that we'll have to find pOH first, then we take that from 14 to give us the pH. So help me work that. What shall I do? Concentration is given, and I know that pOH equal to negative log of the concentration of OH minus ions. So let's do the substitution and evaluation. So I have pOH equal to negative log into bracket 2.9 times 10 power negative 14. So what will be the pH? So when you have the value there, this one is for you. So I have no hand in this one. So you have the value there, then you take it from 14, and that gives you the pH. Is that okay? Yeah, you are following carefully. You realize that this is very, very simple work, which without me, you should be able to go through. When you go to say somewhere as an examination question, you should smile at the question and then work out. The concentration of hydrogen ions in a bottle of wine is 3.2 times 4. Some of you drink wine. If you drink wine, please don't drink alcoholic ones, because they are not good for you. Find the pH of the wine. So here is simple. The hydrogen ion concentration has been given as 3.2 times 10 power negative 4. So do your substitution, quote your formula, do your substitution, and then you get that answer as 3.49. Follow carefully. The third way of doing it, here you are given a solution. That solution will release H plus ions in solution or OH minus ions in solution. So example, the question number 6 is talking about ACl solution given, H2SO4 solution given, and then barium hydroxide solution also given. The concentrations are given. Here, how do I handle this? It's very, very simple. These are strong acids and strong bases, so it will dissociate completely in solution. So if you dissociate completely in solution, then you have to do that. The first one is so simple. ACl. Oh, very, very simple. Or it's not simple? Very, very simple. So HCl, I will have my HCl producing H plus Cl minus ions in solution. What is the concentration of HCl? It's given as 1.0 times 10 power negative 3 mole per dm cubed. So here, from stoichiometry, you use mole ratios. The relative amount of reactants reacting to produce relative amount. So here the reactant is HCl dissociating to produce product H plus and then Cl minus. So you compare mole ratios. From the mole ratios, you realize that 1 mole HCl is equivalent to 1 mole H plus. That is our interest. The H plus is our interest because we are to calculate the pH of the solution. So that tells us that the moles, that is N of H plus, equal to 1.0 times 10 power negative 3. From there, we can quote the concentration of H plus to be 1.0 times 10 power negative 3. So you go and substitute that into our working formula. pH equals to negative log concentration of H plus ions in solution. So you do that. I'm sure you have gotten the answer. The next one too, you do dissociation because that is H2SO4. H2SO4 is the most densest acid, strong acid in our SHS labs. So take note of that. That one too, you do dissociation. So H2SO4 to H plus SO4 to minus. But we have A2 in the reactant. We have only one H in the product. So we need to balance. So balancing, you place 2 in front of the H plus. So 2H in the reactant, 2H in the product. But the concentration of H2SO4 is 1.0 times 10 power negative 6. So here too, you compare mole ratios. So 1 mole of H2SO4 is equivalent to 2 moles of H plus. Then you compare. So what will it give? The same way, you can also write it as N of H2SO4 on N of H plus equal to 1 on 2. So now you know the N of H2SO4, and then we can calculate the N of H plus. So it means that the N of H plus will be twice that of H2SO4. So you do that calculation as well. All we are talking about, you were working alongside. So the answers are here. The first one we have worked. The answer is here. I hope you got it right. If you have not gotten it right, then you have to look at it here. We did the dissociation. We compared mole ratios. We we found the concentration of H+, and then we quote our working formula and did our evaluation. I hope you got it, because it's so simple that you must not think too much. All you need to do is to find the concentration of H+ ions and do your substitution and evaluation. That's all. The second one is also here. I hope you got that one to write. The pH is 1.81. I hope you got that one to write. If you are getting it, smart to yourself, because it's straightforward and simple. Last one here at question 6 has to do with a base. So with the base, there will be OH minus ions in solution. So here too, I'll dissociate. We have barium 2 plus 2 OH minus ions. So what is the concentration? Is 0.02 mole in 1 dm cubed. So all the calculations we are doing here is in 1 dm cubed. That is 1000 cm cubed. So it means that the moles of the barium hydroxide is 0.02 mole. And here too, the mole ratio is 1 mole barium hydroxide is equivalent to 2 moles of OH minus ions. So it means that the moles of OH minus ions will be twice that of the barium hydroxide. From there, don't forget, we are looking for pH, but we have OH minus ions in solution. Therefore, we are going to look for pOH. So you quote the working formula, pOH equal to negative log of OH ion concentration. So when you do that, then you quote the other formula to be pH plus pOH equal to 14. So whatever you got here, you take it from 14 to give you the pH. Take note, you have to ask yourself if the answer is reasonable. So because the pOH will be high, because we are dealing with a base, so the pOH will be high. So the H+ ions must be low. And that is how you determine whether you are right or wrong. So if you are following carefully, you should have your pOH to be 1.40. And then take it from there, and then we have that. You see, so this is a basic solution. So the pH will be high. If the pH is low, you will say that the solution is acidic. So that is how you can determine high pH basic solution, low pH acidic solution, equal pH, you know. Okay, moving on. This is the last aspect where two solutions are mixed, a base and an acid are mixed, and we ask you to calculate the pH of the resulting solution. And when you go for practical work, you are titrating acid and base. You put the base into the conical flask most of the times, put the acid into the burette most of the times. You add an indicator to the base, then you titrate. The indicator changes color. You take your values on the burette, then you do your calculation. In that practice, we can ask you to determine the pH at which the indicator changed color. And you should be able to calculate it. Very simple and straightforward. So if you follow carefully with all you have gotten so far, you should be able to do that. So the next time you enter the chemistry lab and you are running acid-base titration, after all is over, relax on calculating the pH at which the indicator changed color. So this is a typical example that you can get as an examination question, or you are playing with it. Oh, I've gone to run this titration and these are my titer values and my pipette volume, I know it, I know the concentration, I have calculated it. Then let me find the pH at which the indicator, the meter orange or the phenolphthalein indicator changed color. So it's simple. Let's look at it. The volume is given here as 50 cm cubed solution of the concentration is also given, ACl, and is added to the volume of the base 300 cm cubed. And of course the base has a concentration 0.09 mole per dm cubed, pOH solution. Determine the pH of the resulting solution. So here the volume of the acid is given, the volume of the base is also given, and of course the concentrations have also been given. So what should I do? Concentration given, volume given. So I can calculate the number of moles of the acid, calculate the number of moles of the base. Now what should I do? If I calculate the number of moles of the base and that of the acid, you look at the two values carefully. The one that is larger tells us that the ions for that one is more or is excess in solution. So let's say we do the calculation and then the value of the H plus is higher. That means that we have excess H plus ions in solution. So you take that of OH minus ions from the H plus and then you find that difference. So let's look at it. Please follow carefully. What do I do first? I know the volume of the acid to be 50 cm cubed. Then the concentration is 0.0200 mole per dm cubed. So I can find the number of moles of ACl, that is the acid. So I'm going to have 50. Please don't forget, you must change the cm cubed into dm cubed. And we know that 1000 cm cubed equal to 1 dm cubed. So if we are changing from cm cubed to dm cubed, we are going to divide that value by 1000. That is why in the substitution we have 0.050 to do that. I can also have it as 0.0200, that is the concentration, times 50 times 10 power negative 3. But some of you, when you are in an examination, you will say that examination tension. So you forget to bring the negative. The moment you forget to bring the negative, please, it will go against you. So choose the one you can easily handle under examination conditions. I can also have it as 0.0200 times 50 all on 1000. So 3 ways. Number 1 way is to multiply by 10 power negative 3. And then the 50 or the volume is as it is given in cm cubed. Or you multiply by 50 as it is given. You divide all by 1000. If you forget to divide all by 1000, that one too, there will be a problem. The third way is to do it as you have originally seen, as divide the 50 by 1000 before you do the substitution. Whichever one you are conversant with, please go ahead and use it and be versatile. Don't say my teacher says I should divide the 50 by 1000 before I do substitution. Then that is where I will be. No. Understand it in your own ways and be able to handle it under whatever condition you may find yourself. Right. So do it the other ways, the 1 way, 2 ways, and the original one, you will still get the same answer. So if you do that well on your calculator, you should have 0.001 mole. That is the number of moles of the HCl. Then you do that one also for the KOH, the same way. That is why for the KOH, I'm using a different method so that you know that it is not one way. Do it in your own convenient way that you are so comfortable with, that whenever, even when you are sleeping, somebody wakes you up, you should be able to do it without struggle. That's what I want you to do. So the KOH too, you find the number of moles because you know volume, you know concentration. So if you do it well, you're going to get 0.0027 mole. Now, listen carefully. Here, the HCl releases only 1 H plus ions in solution, so you don't have a problem. The KOH also releases 1 of OH minus ions in solution. That one too, you don't have a problem. So you go straight to the point. Now compare the two values. Which of them is larger? If you compare, you realize that we have 0.0027 mole for the KOH, which is larger than 0.001. So it means that we have excess OH minus ions in solution. So let's find the excess. Take the moles of H plus from the HCl from that of the moles of KOH. The OH minus ions from KOH, because the ratio is 1:1. So the moles of KOH equal to the moles of the OH minus ions equal to 0.027 mole. So you do that. Find the difference. From the difference, now you have the moles of the excess OH minus ions in solution. What next? You mix two solutions together, so you must find the total volume. The volume for the acid is 50. That for the base is 300. So I'm going to have 50 plus 300, and that gives me 350 cm cubed. That is the total volume of the two solutions. From there, I will now calculate the concentration of the excess ion. Here we are dealing with excess OH minus ions. We know volume 350, we know number of moles 0.0017 moles. So I can calculate the concentration of the OH minus ions. So we have moles. So C equal to moles on volume. Please don't forget the volume must always be in dm cubed. And most of the cases, the volumes are given in cm cubed. So don't forget to change to dm before you do your substitution. So here, N equal to 0.0017 divided by the volume in dm cubed. So you have 0.017 on the 350 change to dm will give us 0.350. So in effect, we have 0.0049 mole per dm cube being the concentration of OH minus ions in solution. Now, everything is over. What again? Our working formula. So we are dealing with OH minus ions. Therefore, our working formula will be pOH equal to negative log concentration of OH minus ions. So do the substitution and find pOH. The question says you should find a pH. So if you find a pOH, take it from 14 to give you the pH of the resulting solution. So if you do it well, you should have this. You see, the pH is high. That tells us that the resulting solution is, you got it there, basic. Is that okay? If you have not gotten it, please, you go back and reinforce your work. Question number 8. We are still applying what we have learned, the concept, the formulas. We want to put it together. We want to be so used to the calculations, the simple calculations that comes under pH and pOH calculations. Question number 8. Here too, we are talking about acid, H2SO4, volume given, concentration given, KOH, volume given, concentration given. So what should I do? You know, find the moles, find the excess. Which one is excess? But don't forget, the H2SO4 here is producing 2 moles of H+. So when you find the moles of H2SO4, you multiply by 2 to give you the moles of H+. Before you go and do the comparison and do your subtraction and continue from there. So everything is worked for you here. So here, this is a typical titration setting involving H2SO4 and KOH. So in a titration process, using meter orange as indicator, 18.2 cm cubed of 0.100 mole per dm cube H2SO4 is required to neutralize 25.0 cm cubed of 0.0278 mole per dm cube KOH solution. Determine the pH at which the indicator changes color. So it's simple. As we saw already, it's the same format. So the solution is beautifully presented here. You can go through on your own and then get the right thing. So find the moles H2SO4 And then don't forget 2 moles of H plus is being produced, so the moles of H plus ions will be 2 times that. Then you work for the KOH also. After the KOH is releasing only 1 OH minus ions in solution. So that one, there's no problem there. You then compare which one is greater. You realize that we have excess H plus ions because that has the greater value than that of the OH minus ions. So you do your subtraction from there to give you the moles of excess N of H plus ions. And of course, the total, that is, at the end of your titration, you have a total volume in your conical flask. You added 18.2 from the burette. And of course, that is your average volume. And then you pipetted 25 of the base. So it will give you a total of 43.2 cm cubed. And of course, don't forget, you need to change that to dm cubed. So it will give you 0.0432. So of course, concentration, as usual, N on V. V must always be in dm cubed. So you have that to have your concentration as 0.0682 mole per dm cube. That is the concentration of the H plus, because when we worked, the H plus was in excess. So the resulting mixture, reaction mixture in the conical flask is slightly acidic, and that caused the change in the indicator color. So from there, we can have pH equal to 1.67. And of course, the pH is low. Therefore, the resulting solution is acidic. Don't forget. See, we have a lot of questions. So at the end of this, please go and look for more questions, because the more you solve the questions, the more you become so used to the formulas and the concepts that you have just learned. Please keep on practicing. As it is said, practice makes perfect. I want you to come to a point where you'll be working and sometimes you even be sleeping whilst working. And that is the most interesting thing in the life of a student. Question number 9. Here too is on titration, because I'm using indicators here. So that tells you that practically you can do this in the lab. So please, the next time you go and run acid-base titration, come on, play with it. Ask yourself, hey, what pH has this changed color? Do the calculation and see. And you'll be glad to do that. Here, a student titrated 24 cm cube of 0.0200 mole per dm cube Ca into bracket OH. 2. Solution against 25 cm cubed of 0.0100 mole per dm cubed H2SO4 solution using phenolphthalein as indicator. What is the pH of the endpoint? So do that calculation. Here, take note. The Ca into bracket OA2, that is calcium hydroxide, is releasing 2 moles of OH minus ions in solution. And then the H2SO4 is also releasing 2 moles of H plus in solution. So don't forget, after you find the moles of calcium hydroxide, don't forget you find twice for the OH minus ions. And then the acid too, you do the same thing. Compare which one is excess in solution. That will tell you whether the solution is acidic or basic. That is the end point. So you can calculate that one. So do that and see what you will get. You change the 24 to dm cubed, you do your substitution, multiply by 2. So please don't forget, you can leave your answer like this. That is 0.00048 mole, or you can leave it in a standard form. I don't want you to be so static on whatever you are doing. You might, if you leave your answer in standard form, nobody will penalize you. You'll get it as somebody who leaves the answer that way. So the calcium hydroxide is releasing 2 moles of OH minus ions in solution. So the concentration will be twice. The OH minus ion concentration will be twice. And then the acid too will also be twice. Don't forget to do that one also. So the acid too, we have it there. Twice H plus. So 2 times what you got for the H2SO4. Twice that. Then you have that. Which one is larger? Which one is larger? For the OH minus ion, we have 9.6 times 10 power negative 4 mole. Then for the acid too, we have 5.0 times 10 power negative 4. So you agree with me that we have excess OH minus ions in solution. So find that. You find that 4.6 times 10 power negative 4 moles. And of course, what is the total volume in the conical flask? You add 24 plus 25. That gives you 49 cm cubed. So you calculate the concentration of the OH minus ions. And of course, N on V. V must always be in dm cubed. Don't forget this one. Because if you forget, whatever you are doing will be wrong. So don't forget, okay? Yes. So we do that, we have 0.00939 concentration of OH minus ions, and then pOH, you calculate that, take it from the working formula, that is 14, and give you the pH. High pH, what does that tell us? Basic. So it means that the mixture in the conical flask is basic. That causes the change in pH. Right, so viewers, we have been looking at the ionic product of water, and we said that it is the product of the hydrogen ion concentration times that of OH minus ion concentration. We also define pH as negative log of the concentration of hydrogen ions in solution. From there we define pOH to be the negative log of OH minus ion concentration in solution. We establish the relation between pH and pOH, and that has given us a working formula as pH plus pOH equal to 14. I said if you forget all things, don't forget that one also. So next time you see questions like this, don't panic. Look at the plenty questions we have worked. About 9 questions. Oh, you should be able to play with other questions that may come your way. So from here, please don't go to sleep. Go look through the past questions and see if you can find questions on what we have done today. And play with them. When you get them correct, you'll be happy. Means that you are really following. If you don't get them correct, please go back to the concept, go back to the formulas, and then reinforce your learning and come back. Thank you so much for being around through this lesson. As usual, my name is Wisdom Agbesinyale, and don't forget, with you one. Till we meet again, keep on enjoying chemistry.
Subscribe to our YouTube channel, Joylearning TV.